PN junction diode. First we have to see our agendas. The agendas are introduction, forward bias, reverse bias, types of diode, characteristic of PN junction, types of PN junction. Next, first of all, we have to see our introduction. Introduction. Diode. The diode is the simplest and most fundamental nonlinear circuit element. Just like resistor, it has two terminals. Unlike resistor, it has a nonlinear current voltage characteristic. It was used in rectifier in the most common application. Next, we have to see our forward bias. A forward biased diodes conducts current in a forward direction. Next point, a forward biased diode conducts current as long as a high external bias voltage with current polarity is applied. This is our forward bias. Next we have to see our reverse bias. Reverse bias. Extremely small current flows through the diode during reverse bias. The minority carries are forced towards the junction where the combination and spend an extremely small current. This is our reverse bias. Next we have to see our types of diodes. There are 5 types: PN junction diode, Xenon diode, Schottky diode, light emitting diode, photodiode and pin diode, etc. Next we have to see characteristic of a PN junction. Forward bias. The curve draws distance voltage across the junction along x-axis and current through the axis y-axis. Reverse bias. Potential behavior at the junction increase resistor increase and prevents current flows. Next we have to see working of a PN junction. First point, PN junction diode acts as a rectifier as seen in the IV characteristic. Setting current flows in the forward bias mode. Eligible current flows in reverse bias. This property is used for the conversion of AC to DC. So thank you. I am P. Vishali from 1st EC department. Thank you. The presentation is field effect transistor. Next we have to see our agenda. Introduction, JFET and MOSFET. We have to see in introduction is field effect transistor. JFET means junction field effect transistor, and next MOSFET means metal oxide semiconductor field effect transistor. First we have to see our introduction. Introduction. The field effect transistor is a type of transistor that uses an electric field to control the flow of current in a semiconductor. FETs are also known as unpaired transistors since they involve single carrier type operation, that is FET uses either electrons or holes. Most widely used transistor is the MOSFET. JFET, junction field effect transistor. JFET or junction field transistor is one of the simplest type of field effect transistor. The current flow is due to majority and minority change carries since only the majority is unidirectional. The first working model of junction field effect transistor was made in 1953. This is our JFET. Next we have to see our MOSFET. MOSFET stands for Model Access Semiconductor Field Effect Transistor. It is field effect transistor. A MOSFET is based on the modulation of charge concentration by a MOSFET capacitance and insulated from all other device region by gate dielectric layer. So this is a MOSFET. So thank you. I am P. Vishali from 1st EC department. Thank you.
Hi, I am Shivarni, Electronical Communication Department, Dr. Umayal Ramanathan College for Women. Introduction. The Hartley oscillator is an electronic oscillator circuit in which the oscillation frequency is determined by the turned circuit consisting of capacitors and inductor, that is an LC oscillator. The Hartley oscillator was invented by Hartley while he was working in the Research laboratory of the Western Electric Company. The circuit was invented in 1915 by American engineer Ralph Hartley. Hartley accelerator diagram. Hartley accelerator circuit and working. The circuit diagram of a Hartley accelerator consists of an NPN transistor connected in a common emitter configuration. It works as the active device in amplifier stage. R1 and R2 are biasing resistor. CC1 and CC2 are the coupling capacitor. L1 and L2 are inductance. RFC is the radio frequency choke, which provides the isolation between AC and DC operation. At high frequencies, the resistance value of this choke is very high, so it can be treated as an open circuit. The reactance is 0 for DC condition, hence causes no problem. For DC capacitor, the C is the emitter bypass capacitor. RE is also be a biasing resistor. The CC1 and CC2 are the coupling capacitor. When the DC supply is given to the circuit, the collector current starts racing and begins with the charging of the capacitor C. Once capacitor C is fully charged, it starts discharging through L1 and L2 and again start charging. This back and forth voltage waveform is a shine, a small and lights with its negative alteration. It will eventually die out unless it is amplified. Hartley accelerator circuit using op-amp. The Hartley accelerator can be implemented by using an operational amplifier. This type of circuit facilitates the again adjustment by using feedback resistance and input resistance. In transistorized Hartley accelerator, the given depending upon the tank circuit elements like L1 and L2. Whereas in op-amp accelerator again in less depends on the tank circuit element, hence profits greater frequency stability. The operation of the circuit is similar to the transistor version of Hartley accelerator. The frequency of acceleration for this type of accelerator is same as the above discussed accelerator and is given as formula FO equal to 1 by 2 by root LUQC, where LUQ equal to L1 plus L2 plus 2M or LUQ equal to L1 plus L2. Application. The Hartley accelerator is to produce a sine wave with a desired frequency. The Hartley accelerator are mainly used as radio reverse. Due to its wide range of frequencies, it is the most popular accelerator. The Hartley accelerator is suitable for accelerator in RF range up to 13 MHz. Constellation. This is all about Hartley accelerator circuit theory, working and applications. The personal feature of Hartley accelerator is that the turned circuit consists of a single capacitor in parallel with two inductors, or in series as a single tapped inductor, and the feedback signal needed for acceleration is taken from the center connection of the two inductors. Thank you.
Hi, this is Preeti Leela from 1st EC from Dr. Umayal Ramanathan College for Women, Karaikudi. Today, my purpose here is to teach you a topic called Thevenin's theorem from Unit 4, Circuit Theorem and Network. Thevenin's theorem states that it is possible to simplify any linear circuit irrespective of how complex it is to an equivalent circuit with a single voltage source and a series resistance. Let us understand the Thevenin's theorem by an example. Step 1 is to remove the load resistance in a given circuit. In the given circuit, 40 ohm is the load resistance because it is located at the center. So first step is to remove 40 ohm. Step 2. Remove the voltage sources. Here 10 volt and 20 volt are the voltage sources. We should remove that by short circuiting it. If current is present in a circuit, we should open circuit the voltages given in the circuit. Step 3. Find the equivalent resistance. In a given circuit, 10 ohm and 20 ohm are connected in parallel. So, to find the equivalent resistance, formula is RT is equals to R1 into R2 by R1 plus R2. R1 is equals to 20 here and R2 is equals to 10 here. Finally, the equivalent resistance is 6.67 ohm. Step 4. Find the equivalent voltage. To follow this step, we should reconnect the voltage sources which we have short circuited at last step. After reconnecting the voltage sources, we should find current I is equals to V by R, which is equals to 20 volt minus 10 volt by 20 ohm plus 10 ohm. Finally, the answer is 0.33 amps. The calculated current is common to both resistors. To the voltage drop across the resistors can be calculated as follows. VAB is equals to 20 minus 20 ohm into 0.33 amps, which is equals to 13.33 volt. VAB is equals to 10 plus 10 into 0.33 amps, which is equals to 13.33 volt. The voltage drop across both resistors are same. Step 5. Draw the Thevenin's equivalent circuit. The Thevenin's equivalent circuit consists of a series resistance of 6.67 ohm and a voltage source of 13.33 volt and 40 ohm load resistance. To find the current flowing through this circuit, I is equals to V by R. R is equals to 6.67 ohm plus 40 ohm because these both are connected in series. So, finally, the current is equals to 0.286 amps. Thank you.
Relationship between parameters interconnection of networks. Example of two-port networks, transformers, transmission lines, amplifiers, electronic circuit, etc. Next you have C. Parameters of two-port networks. Z parameters, Y parameters. Two-port networks parameters. One-port networks, two-port networks, multi-port networks. One-port networks, a network that is having only one terminals. Next you have C. Two-port networks, a network that has two access ports, one of input and another one for output. Next you have C. Multi-port network, a network which has number of terminals. Next you have C. What is parameters is types. Value parameters, reference parameters, output parameters. Parameters arise as the 4 different types of parameters. Thank you. Muthu Meenal, first EC department.